For today's Do Now, we're going to continue to look at naming and writing the structures for alkanes. So for number 1, you're given a condensed structural formula. I want you to go through, find the longest chain, and name this alkane. For number 2, I want you to write both the bond, line, and condensed structure. So you're going to practice doing both for 2-chloro, 4-fluoro, 3,3-dimethylhexane. And then number 3, I want you to take a look at that name and figure out what is wrong with the name. So based on what you're given with that name, what is wrong with it? So pause the video, answer those 3 questions, and then hit play to go over the correct answers. So let's go ahead and take a look at today's Do Now. For number 1, we're looking at naming this condensed structure. So the first thing we always need to do is find the longest chain. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it looks like no matter which way we go, we have 5 carbons in the longest chain. Now you want to make sure that the carbon chain that you pick has the most number of substituents. So I'm going to take a look. I'm going to use my pencil to highlight the longest chain. So if I went this way, that gives 2 substituents. So this gives me 2 substituents. No matter which way I go, we'll have 2 substituents off of this. So if we count 1, 2, 3, 4, 5, so the longest is 5 carbons, all single bonded, so that's pentane. Now we see that we have 2 CH3 groups. CH3 is methyl. And so since we have 2 methyl groups, we should expect dimethyl. Now you have to number your carbons. You always want to number your carbons so that the substituents have the lowest numbers possible. If I start from left to right, 1, 2, 3, 4, 5, that gives 2, 4. If I number the other way, 1, 2, 3, 4, 5, it still gives 2, 4. So no matter which way you number here, your substituents are 2 and 4. So that means that I'm going to start the name with 2, 4 because you need as many numbers as substituents. So 2, 4, and then we use dashes to separate numbers and letters. We have dimethyl, di because there are 2 methyl groups, and then add the parent name at the end, pentane. So 2,4-dimethylpentane. For number 2, it wants the bond line and condensed structure for 2-chloro, 4-fluoro, 3,3-dimethylhexane. So I'll go ahead and just put a line down the middle here. I'm going to start with the bond line structure and then I'll go over to the condensed. So I'm going to start by looking at the ending, hexane. That means there are 6 carbons in the longest chain. So I'm just going to start by drawing the longest chain. As soon as your pencil hits the paper, that's 1 carbon. So 1, 2, 3, 4, 5, 6. And then I'm going to go ahead and number my carbons just to be safe. Make sure I had the right number. 1, 2, 3, 4, 5, 6. Again, it doesn't matter whether you start left to right or right to left, as long as you're putting the substituents on the correct carbons. So 2-chloro, so off of the second carbon, that means there's a Cl group. 4-fluoro, so off of the 4th carbon, we're going to have a fluorine. 3,3-dimethyl, so off of the 3rd carbon, we actually have 2 methyl groups. Now, if you take a look here, notice how it didn't change the longest chain. Now we're just showing all of these substituents. Off of the 2nd and the 4th carbon, I made them point up because if I made them point down, all of the bonds would be too close together. Same thing for the dimethyl. Notice how I tried to space them out as much as possible. Now for the condensed structure, we're going to do the same thing. So I'm going to start with 6 carbons, single bonded. I'm going to leave some space between the C's just for when I need to put in hydrogen. So 1, 2, 3, 4, 5, 6. So now I have 6 carbons. I'm just going to start my numbering from left to right again. So off of the 2nd carbon, we have a chlorine single bonded. Off of the 4th carbon, we have a fluorine single bonded. Off the 3rd, we have 2 methyl groups. So I'm going to do 1 on the top, showing C single bonded to C, and 1 on the bottom, again, showing C single bonded to C, not an H. Now I'm going to fill everything else in with hydrogen. Remember, carbon wants 4 bonds. So this one at the beginning only has 1 bond. It needs 3 more. So that means it's going to have 3 hydrogens single bonded. This carbon needs 1 hydrogen. This carbon doesn't need any more. 1, 2, 3, 4. It already has 4 bonds around it. So then we have 1 hydrogen, 2 hydrogens, and 3 hydrogens. So there is the condensed structure. And then finally for number 3, what's wrong? So we were given a name. What's wrong with the name? You take a look at this. It's not asking us to compare it to the structure. It just wants to know, based on this name, what do you notice is wrong with it? And maybe at first you don't notice anything, but I always want to point out, focus on the beginning of each of the substituents. This name is in numeric order, not alphabetical order. So we'll answer and we'll say it's in numeric, not alphabetical order. And if we wanted to fix it, it would actually be 4-chloro, because C is going to come first. 3-ethyl, E will come next. 1-methyl pentane. So your prefixes, your substituents, always need to be in alphabetical order. Now we didn't actually have any prefixes here to worry about. Remember, di, tri, those are not included. The only prefix that you count when you're alphabetizing is iso. So here's our answer for number 3.